Hi, I'm Bill McAnally with Touchstone Energy and the Together We Save program. The next wall section we want to show is different types of insulation. Now, we're going to be looking at fiberglass, closed cell foam, open cell foam, and this one is a dense pack type of cellulose. What we want to remember on all of these, we really need to stress to people how important the installation is. Any one of these products works very well if it's installed correctly. Any one of these products may perform very poorly if it's not installed correctly. The hardest one to install correctly is fiberglass. It's cheapest up front. It's by far the most used. But if you're going to really even count your labor, it becomes about the same cost as any of the other products. You have to cut this to fit the stud cavity perfect from inside to inside. It has to be friction fit. It has to go all the way to the top. It can't be bunched up. It can't be folded over in any place, and if there's a receptacle that's in this cavity, that receptacle area has to be cut out. A lot of detail work, and it's really hard to get anybody to put it in correctly unless you're doing it yourself or you have a very reputable contractor. The next product is a closed cell foam. The advantages to closed cell and open cell is you can completely fill the cavity. They do an excellent job of stopping air infiltration. The one advantage to closed cell foam, it also acts as a vapor retarder, whereas the open cell foam, you're still going to have to put a vapor retarder up, like a smart vapor retarder, not the usual polyethylene plastic. The new codes are changing to we need to be using something like certainteed membrane that's forgivable in case we ever get vapor in the cavities. So you're going to have to be using a smart vapor retarder on fiberglass, open cell, and cellulose for them to actually work correctly, because we have to stop the air as well with cellulose and fiberglass as well as vapor. But remember, vapor still goes through open cell foam, so we have to remember that. The big key with both of these is just making sure that the cavity is allowed to fill at the right proportion, that the temperature's right, because sometimes we'll get a cavity inside an air cavity when they're expanding, an air cavity in there that kind of cuts down on the insulation. On the dense pack cellulose, this one here has already dropped an inch because we've seen it go down the highway on displays, and the house isn't going to be bouncing around. But when this is put in, usually the installer will say it's going to settle 1%, and that's roughly this amount over a period of time. So you would have an inch gap on top of your insulation all the way around the top plate of your house. So that's the only disadvantage to the dense pack. So when you put in a stabilized, or we used to call it dense, not dense pack, we used to call it a stabilized or wet spray. Anytime there's a stabilizer, a latex, or moisture put into it, it's like a big spitball. It goes into the cavity and stays there. It's not going to settle. But the key to that is you have to let that dry to 15% moisture content before you drywall. It's not a case where you can just go ahead and throw the drywall up in 2 days. If the salespeople are telling you you can cover it in 2 days, the first thing you want to ask is what moisture content does the center of that cavity have to be before I can cover it, so allow it to dry. If you don't allow it to dry, you're asking for mold and moisture problems. Well, we've got a nice little display that usually goes with this one. What it's trying to show is heat and air movement through a wall cavity. When the lights are turned on, it's going to create heat, and you'll be able to see the temperature readings on the gauges, and then the fan will start up and it'll push the ping pong balls to the top. Of course, the ping pong ball isn't going to move when you have a product that completely seals the cavity. But here you've got fiberglass and it's blowing air through loose fiberglass. Now the difference is on an actual house, you're going to have a vapor retarder and you're going to have foam on the outside. So if you get somebody that comes to the display and wants to argue this point, you have to say, well, in a real wall cavity, you're going to have sheeting on the outside, vapor retarder on the inside. The air movement isn't going to be that much different, but the heat will, because the heat transfers through the fiberglass a lot more than the foam does. So you just, if somebody comes and asks, you have to be able to explain what's really going on here.